Yes, students, in this video, we are going to discuss one more important antenna parameter, effective height and aperture efficiency, antenna beam width, antenna temperature, and polarization. All these uh, different parameters we will discuss in this video.
Discuss another parameter called effective length. We discussed effective area. Similarly, we discuss effective length. Represented with HG, or I can represent with L effective. So effective length HG or L effective. The same thing. Okay. As we are in the previous case, we have as a concept that entire portion, only some portion get received effective, that we call as effective area. Okay. Similarly, here also the term effective length of an antenna represents the effectiveness of an antenna as a radiator or collector of electromagnetic waves. Okay, so the term in the effective length of an antenna. Yeah. Represents the effectiveness of an antenna as a radiator or collector of electromagnetic energy. So this is the definition. So for example, let us consider the receiving. So for a receiving end, then the definition of the effective is the effective length of effective length of effective is the ratio of induced voltage at the terminal of the receiving end. Open circuit condition to the incident electric field. Effective length H effective is equal to by this is under effective. So another electrical field, what is the expression for the electrical field? Expression or unit is volts per meter. Okay, volts per meter. This is equal to E. So this is the other definition. So for example, consider a vertical dipole of length L. Consider a vertical dipole of length L is equal to lambda by 2. So let us consider this is the antenna. Okay. So the total length is physical length. Physical length is L. Physical length is L, where the L is equal to lambda by 2. The physical length is L. Okay. So if we observe the current radiation pattern, current radiation pattern will be like this. Sinusoidal current distribution. Sinusoidal current distribution. But so only if this is the total length, this is the total length. Only in this some portion will receive electromagnetic. Okay. So from here to here only it will receive the electromagnetic. This is called as H. Whatever the portion that is received effectively, that is called as H or as Ln. Okay, so means it means here the physical length physical length is L. Effective length is HER L effect. Always HER L effect is always less than physical length L. Physical length L. Physical length L. Okay. So actual current distribution is, however, sinusoidal with an average of 2 by 5, that is equal to 0.64 of maximum value. So therefore, the effective height HG is equal to 0.6 of physical length. Okay, so effective length is equal to 0.63 times of physical length. Okay, 0.63 of. Okay, now let us bring the relationship between. Let us bring the relationship between the effective length the relationship between let us bring the relationship between relation between effective height, effective height, HG, effective area or antenna aperture, area, effective aperture area is AE and directivity. So we want to bring a relationship between directivity, effective aperture, effective height, H, and effective aperture area, A. Okay, so we want to bring a relationship between these three. Okay, so we know that in the previous expression, P received by an antenna, power received by an antenna is given as VOCC square by 8 rated. This we have derived in while deriving the relationship between directivity and effective aperture area. P received is equal to VOC square by 8. What is the formula for the effective height? We have given effective height is equal to VOC by E. On this, what is the expression for VOC? VOC is equal to H. Okay, now in the place of VOC, I'm substituting H in this equation. So we receive that is equal to square to effective height whole square by 8 R 8 R. Okay. So square to 8 R rate. Okay. So this is the formula for P received. Okay. Next, what is the effective formula for effective aperture area A? It is the ratio of P received by P average to the ratio of P received. From this, what is the formula for the P received? Let us give the expression for P received. It is A. Okay. So from this, what is the formula for the P received? P received is equal to effective aperture area A to A average. Okay. So we know that for an HN by 4, for an HN by 4, the average is equal to that the average is equal to square by 2. So therefore, simply substituting P received is equal to A into With the value of P average, the value of P average is P square by 2. Okay. So this is P. Okay. Here, this is expression A. This is the formula for P received, and this is expression A. And similarly, this is P received, this is expression P. Okay, okay. Now I am comparing A and comparing A and B. So if I compare A and B of the expressions, square into effective height whole square by into R pad is equal to AUM into square by 2 beta square by 2 beta. So things will get cancelled. This square will get cancelled. Comes to force. So H square is equal to E to R to 4 by eta. Therefore, H is equal to effective height. Effective height is equal to root of E to so use the relationship between so effective height H is equal to 2 into A effective aperture area into radiation by 2 beta. Okay, so sorry, here it is not directivity, it is R rate. It is R rate. So this gives the relationship between. So effective height H is equal to 2 into root AEM by R radiated by eta. So this is the derivation for the effective height in terms of effective aperture area and in radiation resistance. So we will discuss another parameter called as aperture efficiency. Called as aperture efficiency. With epsilon aperture efficiency. Okay. So aperture efficiency is the ratio of aperture efficiency is the ratio of maximum effective area of the antenna to its physical area. Its physical area. AP denotes the physical area and AEM denotes the effective aperture. Means this is nothing but, for example, this is my overall physical area. This is my physical area. In this, only this portion is effectively utilized for transmitting or receiving the electromagnetic waves. So this one we call it as effective area. This one is effective area and this one is physical area. Which one is more? Always the physical area is more when compared to the effective area. Okay, compared to the effective area. Okay, so therefore epsilon AP is equal to effective area by physical area. So among this one, which one is more? Always the physical area is more when compared to the effective area. So since the physical area is in denominator, always the value of aperture efficiency is always less than the range of effective aperture efficiency is in between, so less than. So always since the effective area is always less than or equal to the physical area. Okay, so this is the definition of aperture efficiency. Aperture efficiency is the ratio of maximum effective area AEM of an actor to its physical area. Okay, second to its physical area AEM is equal to AP. Okay. Next, we'll discuss on the parameter called antenna beamwidth. Antenna beamwidth. Discuss. So it is the range of frequencies. The definition is the range of frequencies which maintains its certain characteristics by the radiation resistance. Yeah, SWR impedance to the specific value. To the specific value. Okay, so this is nothing but the definition of antenna bandwidth is equal to 12 is equal to omega 2 minus omega 1 that omega r by q. Okay, the same thing we can write it as is equal to delta f is equal to f2 minus f1 by f1 by q. Okay, where f by omega alpha r omega is nothing but resonant for omega but resonant frequency and Q is quality. It is quality. It is quality. We will discuss another parameter called as antenna temperature. Temperature. So what is this antenna temperature? Whenever an antenna is transmitting or receiving, automatically some heat comes into picture. So the definition of antenna temperature is it is the fixtures. Is the fixtures temperature. The fixtures temperature at the input of an antenna. Which should account for delta M at the output. Where delta is frictional noise introduced by the antenna. By the antenna itself. By the antenna itself. So this is the other parameter called as antenna temperature. This is called as antenna temperature. Okay. So discuss polarization. Polarization. What is the definition of polarization? Polarization is orientation of an electron. Orientation of an electron. And electric field is known as polarization. So coming to the polarization, there are different polarizations of the linear polarization. Other one is circular polarization. Circular polarization. What is meant by this linear polarization and what is the difference between circular polarization? So, for example, you are able to talk with your phone. Okay. For example, let us consider this is your mobile phone. Okay, so if your antenna, whatever the antenna you are using, your antenna is not circular polarized one, compulsorily you want to talk with your phone like this one. If you rotate your antenna like this, the E tangential component becomes zero to the surface and signal will get attacked. But how you are talking, you are talking your mobile phone in any angle. Even though you are talking your mobile phone, even though you are talking your mobile phone in any direction, you are getting the signal without uh, without disconnection. Okay, but if your mobile phone antenna is operating only for linear polarization, compulsorily you should shift like this and want to talk only in this fashion. But whatever the antenna you are using in your mobile phone, it is discrete, circular polarized signal. That's why, since it is circular polarized signal, you can talk like this or you can talk like this, you can talk any direction. Okay, so circular polarized antenna capture the signals in any direction. Okay, so this is the things that is regarding polarization.